Hey team, welcome to the numbers game. I'm Coach T, and in this tutorial we'll be going over properties of relations, that is the reflexive, symmetric, and transitive properties. We're going to go over their definitions as well as look at their corresponding diagrams and their ordered pairs and all of that stuff. So let's go ahead and dive right on in and start with our reflexive property. The reflexive property's definition states that our relation is reflexive if and only if all of the x's in our set A exist such that x is related to x. So basically what this means is that we've got this ordered pair where the element in the x position and the element in the y position are the same element. So let's take a look at what this diagram looks like. In our diagram, we have a set that includes elements 1, 2, and 3. And this set is reflexive when first 1 goes to 1, giving us the ordered pair 1, 1. Next, 2 must go to 2, giving us ordered pair 2, 2. And finally, 3 will go to 3, giving us ordered pair 3, 3. This is our diagram for the reflexive property. All of our elements here are reflecting back onto themselves. So this diagram is reflexive. And now let's move on to the symmetric property. The definition of the symmetric property states that the relation is symmetric if and only if all of the x's and y's in our set exist such that if x is related to y, then y is related to x. What this basically means is that we should have ordered pairs xy and the reverse yx. Now let's take a closer look at the symmetric property in our diagram. Again, we've got this set with elements 1, 2, and 3, and this set is symmetric when 1 goes to 2, giving us ordered pair 1, 2, and 2 must also go back to 1, giving us the ordered pair 2, 1. 2 will go to 3, giving us 2, 3, and 3 will also go back to 2, which gives us 3, 2. And I'll go ahead and follow this same pattern to finish illustrating the relationship between elements 1 and 3. And this gives us our last couple of ordered pairs, 1, 3, and 3, 1. Taking a look at all the ordered pairs we just came up with, we see that for every ordered pair xy, we have a yx in return. And so this set, therefore, is symmetric. Now let's go ahead and move on to our final property, the transitive property. All right, the transitive property states that our relation is transitive if and only if all of the x's, y's, and z's in our set exist such that if x is related to y and y is related to z, then x is related to z. What this means is that we should end up with 3 ordered pairs, xy, yz, and xz. You know, this is where drawing out diagrams really becomes super helpful because we can correlate some of these variables that we have or these x's, y's, and z's that we have in our definition to the elements that we have in our diagram. So for the purposes of filling out this diagram, let's say that 1 correlates to x in our definition, 2 correlates to y, and 3 will correlate to z. So our definition states that x is related to y. In our diagram, that means 1 is related to 2. Next, we see that y is related to z, so 2 is related to 3. The last part of our definition states that x is related to z. In our diagram, that means 1 is related to 3. So following our definition closely, we were able to fill out our diagram and end up with our 3 ordered pairs, that is 1, 2, 2, 3, and 1, 3. This is a diagram that illustrates the transitive property. So there you have it. We've gone over 3 properties of relations, that is the reflexive property, the symmetric property, and the transitive property. I'm going to go ahead and leave you guys with an example to do on your own. Okay, boom. So this is you all's example to do on your own. Y'all have a set. Tell me, is this set reflexive, symmetric, and or transitive? When you get your answer, drop it down in the comments below. I'll also leave the answer in the description box, but don't take a peek before you get your own answer. That would be cheating. If this video was helpful for you, give it a thumbs up, like it, and subscribe to the channel for more math tutorials. I'm Coach T, and thanks for watching the numbers game.